Hello, everybody. Oh my gosh, I miss you guys so much. I can't even tell you how this is not exciting to teach this way because I just can't talk to you guys and I can't see your faces and I don't get to hear your questions. So anyway, I miss you guys and I hope you're doing well and that your families are healthy and that they're well as too, and hopefully you're getting outside and enjoying the sunshine. This is the video for 9.2, so the first video of April 27th to May 1st that week. I'm going to do two different videos. The first day we'll cover day 1 stuff, and then the second day about day 2, and then after that work on the big ideas assignments. And remember, we have meetings. If you guys need any help, meet me in the Google Meets. That's on I'll post them on the Google Classroom, and this also should be in your Google Calendar. So let me know if you don't see any of that or you don't get the invitation, so I can add you to the list. These blank notes are also in the Google Classroom, so you can either print them out if you have that capability, or you can just write out on paper as I go through the notes. And then make sure you pause the video whenever you need to, and let me know if you have any questions. Okay, so we're going to start. This section is going to be looking at angles and radian measure. But we're going to do a little review-ish of the first section, 9.1. So in 9.1, you guys were solving our triangles, and we were using our sine, our cosine, our tangent, trig functions to help us do that. So sometimes when we're solving triangles, we have an angle that we don't know in our right triangle, but we're given two of the sides. So we can use what's called inverse sine, or inverse cosine, or inverse tangent to undo our trig equation so that we can solve for the angle. So that's what we're going to be trying today. So I'm going to look at so hopefully you can read through those notes about using the calculator. So when you're using your calculator, make sure you check the mode. So there's a mode button on the graphing calculators up by the second button. So check to make sure when you push that mode that degree is highlighted instead of radian. We're going to be talking about radians in a little bit. And then you're going to be using the same sine, cosine, tangent buttons, but you're going to push the second button first. Second first, get it? Anyway, you're going to push the second button and then sine to use the inverse sine. And it looks like sine to the -1 power, just like it shows up here in your, it'll look like this, sine -1, or cosine to the -1, or tangent to the -1. And we say inverse sine, or inverse cosine, or inverse tangent. But what it's doing is undoing the sine, the cosine, or the tangent so that we can get the angle. So we're going to start by setting up A here. This is a right triangle, and we have two of the legs. One leg is 45 and the other leg is 34, and we're trying to find that angle where the question mark is. So I'm going to go ahead and put an X next to that angle just to give it a variable to use for when I'm writing. And I'm going to think about which sides do I have in relationship to that angle X. So the 34 is opposite the angle, so I'm going to label that OPP. And the 45 is adjacent to the angle, or next to angle X. So I'm going to label that ADJ. And then I'm going to look at my sine, cosine, and tangent, my SOHCAHTOA. And we put the little key over here for you. So sine, cosine, tangent. And I'm looking at that to think about which of those trig functions do I want to use if I have my opposite and my adjacent. And notice the tangent uses O and A, so opposite and adjacent. So that's what I'm going to set up. I'm going to set up the tangent of the angle. You always write the angle next to sine, cosine, or tangent, equals the ratio of opposite side, which is 34, over adjacent side, which is 45. So that's how I would set up my equation, but I'm trying to solve for x. So I'm going to undo the tangent, which is called inverse tangent, because I want x by itself. So I'm going to undo tangent, which gives me just an x on the left side of the equation. And I have to undo tangent on both sides of the equation. So I have inverse tangent of 34 over 45. And then I type that in my calculator. So I'm going to push second, tangent, and 34 divided by 45. And that gives me about 37 degrees. And the direction tells us to round to the nearest degree. So I'm going to get x is about, and I'm writing this up top because I am out of room, 37 degrees. Please be sorry about my writing. It's not beautiful by any means. Okay, so we're going to try again on B. So again, I'm going to start by labeling the angle as x, and then look at the sides that I'm given. So the 15 is across from the x, so that's opposite. The 13 is the hypotenuse because it's across from the right angle, so that's always your hypotenuse. And so then I go back to my sine, cosine, tangent, my SOHCAHTOA, and look at which one uses opposite and hypotenuse. And this time it's going to be the sine. So I'll write the sine of my angle, which I'm calling x, equals the opposite side, which is 15, over the hypotenuse, which is 18. So you gotta set up your equation first, and then I'm trying to solve for x, so I'm gonna get x by itself by undoing sine. So that's called inverse sine. So then I'd have x by itself on the left equals the inverse sine of 15 over 18. And then I type that in my calculator, so I'm gonna push second, sine 15 divided by 18. And I'm again rounding to the nearest degree, so I'm going to have x, or the angle, is about 56 degrees. So as we're going through these, if you have any questions, like jot yourself a little note, and so you can ask me during the Google Meet for clarification. Okay, C, again, I'm going to go same process. So, and this is you could pause the video and try this on your own, and then check to make sure that you did it right. So I'm going to label my angle as x. I'm going to look at my 24 and notice that's the next to my x, so that's adjacent. The 33 is across from the right angle, so that's of course the hypotenuse. And I'm going to look at my sine, cosine, tangent to see which one uses adjacent and hypotenuse, and that is cosine of the angle equals 24 adjacent over hypotenuse, which is 33. And then I'm going to undo my cosine to get my x by itself. So the undoing is called inverse cosine. And I'm going to inverse cosine the other side of the equation and get inverse cosine of 24 over 33. I type that in my calculator, and it will tell me that my angle is about 43 degrees. Okay, moving on. So here we go. Here's a real life problem. You're flying a kite because it's beautiful kite weather right now. The string is pulled taut and has a length of 120 feet because that's what you know that because you bought it. You bought the roll, 120 feet. And you're holding the kite string at a height of 3 feet. So 3 feet above the ground is where you're holding your kite string. If the string creates a 37-degree angle of elevation from the horizontal, that would be straight out, what's the height of the kite? So I'm going to draw myself a picture. So there's you, and there goes your string, that's 120 feet. And here's the kite. See? Can't even hear you guys listening or, laughing at my picture or anything. So sad. And then here's my horizontal, like my imaginary horizontal line. So that gives me my right triangle. And this is where it says the string creates a 37-degree angle of elevation. So elevation means you're looking straight out and then up. So here's my angle of elevation of 37 degrees. Right there. Angle of depression is when you're looking straight out and then look down. So that'll be angle of depression. And we're trying to find the height of the kite. So first I'm going to solve for this height, and then I'm going to have to add in the 3 feet, the extra 3 feet, because remember you're holding the kite 3 feet above, or the string 3 feet above the ground. So first I'll solve for x. So I'm thinking to myself, well, x is opposite my angle, and the 120 is the hypotenuse. So then, I'm going to use my sine. So sine of the angle, so always sine, cosine, tangent of the angle, equals the ratio of opposite, which is x, over a hypotenuse, which is 120. And then, wait, why did I put an x there? I need this to be 37. I'm so silly. 37. See, you guys would have caught me and told me that in class. So it's really supposed to be sine of 37 equals x over 120. I'm sure you wrote that properly. So now I'm going to solve. I want x by itself, so I'm going to multiply both sides by 120. So I'll have 120 times the sine of 37 equals x, which will give me part of the height I need. So I'll type that in, 120 times sine of 37 into my calculator, and I'll get that x to be about 72 feet. But remember, I need to add in the 3 feet because it's already being held 3 feet above. So after 72 plus the 3 feet will give me about a height of 75 feet. I'll try to write the kite is about 75 feet above ground, or height of whatever, however you want to write that. Oh, so beautiful writing. Okay, so next one, if the kite is at a height of 44 feet, what's the angle of elevation? So we're going to go backwards a little bit. I'm going to sketch in my right triangle. Remember, we've got the 3 feet here. We don't know this height. Oh, wait, maybe we do this time. We do know this time that this whole height is 44 feet above ground. So because you're holding the kite 3 feet above and this total is 44, I can subtract 44 minus 3 and know that that length right there is 41 this time. I still have a kite string of 120, but we are trying to find the angle of elevation. So this time we're trying to find the angle. So now I'm going to use x for my sine of x equals 41 over 120. So we'll have to use our inverse sine this time to solve for our angle. So we're going to undo sine to get x by itself, and that's called inverse sine of 41 over 120. And I'm going to type that in my calculator. And remember, I'm using I push second button and then sine, and I should get about 20 degrees, so that the angle of elevation is about 20. All right, moving on to the next page. Too far. Okay, so this is a little review of our special right triangles. I noticed that on some of the assignments you guys did, some of you were using the sine, cosine, and tangent instead of your special right triangle shortcuts or tricks, whatever you want to call it. So this is a good thing we need to review. So on the 30, 60, 90 triangle, that's at the top on the left, or you're drawing in as right now. We always start with the shortest leg. So that's the one that's opposite the 30-degree angle. So I'm going to call that X, just give it X, and I'm going to also write in short leg, because everything's based on that short leg. Well, I tried to write it in anyway. So we've got the short leg. To get the hypotenuse, we're going to take our short leg and we're going to multiply it by 2. So times 2 gives us the hypotenuse. So we can write then as 2x for the hypotenuse. The long leg, we take our short leg and we multiply it by the square root of 3. So this will be x times square root of 3 for our long leg. So those are our shortcuts that we're going to need to remember. Then on the 45, 45, 90, there's a little bit less work since both of our legs are equal, because both of those acute angles are 45 degrees. So both of these legs, we just call them legs, are the same. I can put x on both of those. And then to get to this hypotenuse, instead of multiplying by 2, we multiply by the square root of 2. So it's close to the other one, but you use square root of 2. So those are our shortcuts. We're going to use those shortcuts and find some missing sides of these triangles right below it. So on A, they tell us one of the legs is square root of 2 over 2, and we notice that our angle is a 45-degree angle. So if one angle is 45, the other one has to be 45 for this to be a valid triangle, because remember, all 3 angles have to add up to 180. We've got a right angle in there. So both angles are 45. If one of the legs is root 2 over 2, then the other leg would also have to be root 2 over 2, because those angles are equal, the sides are equal. And then to go from the leg to the hypotenuse, we're going to multiply by the square root of 2. So square root of 2 over 2 is our leg. We're multiplying by the square root of 2. So we multiply straight across, we get the square root of 4 over 2. And we all remember square root of 4 is 2. So that's going to equal 2 over 2. 2 over 2 simplifies to 1. So that gives us our hypotenuse. It's a very special triangle, and we're going to use it quite a bit. On the B, the hypotenuse is a length of 1. So they're telling us here we've got 1 for the hypotenuse, and that's, remember, the side opposite the right angle. To to find our legs, we could go backwards this time and divide by the square root of 2. So we'd have 1 divided by the square root of 2. And I'm sure some of you are talking out loud to me and saying, why are we doing this? Why don't we just look at A? But if you didn't notice that, then, or if you needed to know how to do this anyway, it's good practice. So I'm going from 1 and dividing by square root of 2, but remember, that's illegal to leave a radical in the denominator. Remember, the math Bible says thou shalt not leave a radical in your denominator. So I'm going to multiply top and bottom of my fraction by square root of 2 over 2. So when I multiply straight across, I'd have 1 times the square root of 2 over square root of 2 times square root of 2. Some people would write square root of 4 and then say to themselves, well, I know that's 2. So then our legs, as they're equal, are both going to be square root of 2 over 2. So that's going both directions. Essentially, it's those two were the same triangle. We just went different directions to find the missing side lengths. And then down here, we've got a different triangle. Everything's labeled for us, and we're asked if the opposite side is 1/2. So I'm going to go ahead and put a 1/2 over there. So if that side is 1/2 and our theta, our angle, is 30 degrees, what we need to find our other side lengths. Well, since that's 30 degrees, then I know that my 1/2 is my short leg. So to get to my long leg, I'm going to multiply by square root of 3. So this adjacent side is going to be 1/2 times square root of 3, which would be square root of 3 over 2. And then to get to my hypotenuse, I'm going to take my short leg and multiply it by 2. So 1/2 times 2 gives me 1. So that's what a 30, 60, 90 right triangle with a hypotenuse of 1 looks like. And so we're going to use those guys in a very special circle called the unit circle. Moving on to the next page. So on this page, we've got our 30, 60, 90 and our 45, 45. No, sorry, just looking at 30, 60, 90. Our two circles at the top with those 30, 60, 90 triangles drawn in for us. And if you notice that when we have a 30-degree angle at the origin, so on the circle on the left, and then we use those shortcuts that we were just reviewing on the previous page of 1/2 and root 3 over 2, and then a hypotenuse of 1. We can draw that right triangle in. That gives us a coordinate of this point out here on the unit circle as root 3 over 2, comma 1/2, because you'd go over root 3 over 2 for your x value, and then you go up 1/2. So using that right triangle to give us lengths, our direction for our point out here. And I guess I should have been more clear. We're talking about the unit circle. A unit circle is super special in many ways, and the first way would be it's called a unit circle because the radius is 1 unit. So that's why it's called a unit circle. So anywhere around that circle, the radius is 1. And it creates these really special points and triangles, and so that's what we're going to be looking into right now. We could also draw in a right triangle. So on the circle on the top right here, we can draw in a right triangle that has a 60-degree angle at the origin. And so that just changes our lengths. So it switches the 1/2 and the root 3 over 2 to the different legs of the triangle. So then our x value becomes 1/2, and then we would go up root 3 over 2 to get that point at 1/2 root 3 over 2. Okay, so we're going to look at this a little bit more. Down below, we have a unit circle, meaning that the radius has a length of 1, and you can see that denoted here on the sides where it has the point 1, 0 and this point 0, 1. So that's telling you that your radius from the origin out to any point is a length of 1. We're going to start by drawing in all of the possible right triangles that with one acute angle of 30 degrees. And this is better if you have a ruler, but I'm going to do my best. Okay, so the dots on the unit circle here were put there to kind of help you count degrees. So each dot is 10 degrees. If you count, there's 9 dots up to 0, 1, so that's 90 degrees for your right triangle. So if each dot is 10 degrees, then I can draw in this first triangle from the origin. Yikes, that's a super straight line. And then down. So this would be my 30-degree triangle. And so this is my 30-degree angle. So I know the adjacent side, the side next to my 30 degrees, it has a length of √3/2. And then I would go, the short leg, or the side opposite my 30-degree angle, has a length of 1/2. So I know that this right side of the right triangle is 1/2. So then this point right here, I would go over √3/2, up 1/2. So that would give me that coordinate point. So I'm going to draw in another 30-degree right triangle. So from the origin to the left side. And because I'm going to the left of the origin, this is going to be a negative √3/2, because, you know, those are negative numbers on the left. But I'm still going to go up 1/2, so this coordinate point is going to be negative √3/2, comma 1/2. Remember, you can always pause the video if you need to replay it, or jot down a question to ask me later. There's some more right triangles that we can draw in. So down below in the third, I'll just keep going. The third quadrant, this guy right here is a 30-degree right triangle. And I'm guessing you can notice it's the same side lengths, but this time we're to the left of the origin and below the x-axis. So both my coordinates, my √3/2 and my 1/2, are both negative. And then I have another right triangle in the fourth quadrant. Oh, that was really bad. Here we go, I'll try again. Well, whatever. So then this coordinate down here is gonna be still positive √3/2, because I'm to the right of the origin, but down to negative 1/2. Just in case anybody forgot, the top right quadrant is the first, and then we go counterclockwise to get to the second quadrant, and then down to the third quadrant, and then over to the fourth. So remember, counterclockwise is how we count our quadrants. And we're going to talk about angles a little bit more in this section. Okay, so now I'm going to go through and draw in those other triangles that have 30 degrees. But at the origin, it's a 60 degree. So 30, 40, 50, 60. It's going to be right there. I wish this had like a line drawer so I would have straighter lines. So this is 60 degrees, and then up here is my 30-degree angle. So the side lengths, or the legs, are going to be the same length, but here's my 1/2. And then up here is my √3/2. So this point is going to be an x value of 1/2, so I go over 1/2, and then up √3/2. I'm going to fill in those other right triangles that look just like that. So that guy right there in the second quadrant. So there's my 60-degree angle. Remember, these are all radius of 1. So this is negative 1/2 on the x. So my coordinate up here is going to be negative 1/2, positive √3/2. And then in the third quadrant, there's my right triangle. So there's my 60 degrees. So this is going to be negative 1/2 and a negative √3/2. And then same thing in the fourth quadrant. So I'd have a coordinate of 1/2 and negative root 3 over 2. What a mess. Hopefully yours looks prettier than this one. Okay, I'm going to move on to looking at the same stuff but with a 45-degree, 45, 45, 90 triangles. So mine is on the next page. So here we go. We have our 45, 45, 90 triangles. At the top of the page here we have our unit circle with a 45, 45, 90 triangle drawn in for you, radius of 1, and then the legs on this right triangle are root 2 over 2. So that gives us that coordinate of the same x and y. So these are kind of a little bit easier, quicker, nicer, whatever you want to say. So we're going to fill all the ones in down below. And so there are a few less of the 45, 45, 90s. And I already have the hypotenuse drawn in. So if we draw in the, fill in the right triangle, and remember the legs would have a length of root 2 over 2. So both the x and the y are root 2 over 2. And that comes from our shortcuts on our 45, 45, 90 triangle, because our hypotenuse or radius is a 1. So then in the second quadrant, we'd have the same numbers, but this is a negative x value because we're to the left of the origin. So in our coordinate up here for that point would be negative root 2 over 2. And then our y is a positive root 2 over 2. Down in the third quadrant, this would be both negative root 2 over 2 for x and for the y. In the fourth quadrant, we'd have a positive root 2 over 2 for our x and a negative root 2 over 2 for our y. So that goes a little bit quicker. All right, that's our day 1. This first introduction to unit circle. Unit circle is amazing, and you're going to use it tons in your future math careers. Anyway, I hope you're all doing well. I don't have any homework assigned for this first video. After the second video, then you can you'll have a big assignment to do. So we'll only have 2 videos this week, 1 assignment, and hopefully you can get that done by Friday. Miss you guys. Hopefully I'll see you on Google Classroom or Google Meets if you have any questions. Bye.